Hey guys, it's Edward. So today, what I'm going to do is a second part to my video on LeetCode problem solving for the problem Serialize and Deserialize a general N-Ary tree. If you haven't seen that first video where I actually solved the problem and walked through my thought process, I'll link it here. But today, what I'm going to do is take an incorrect solution that was given by one of my clients and then critique it as if I had made the mistakes. I'll show you my thought process that I go through in order to try and fix any mistakes and, most importantly, learn from them. After all, we're not going to always solve every single LeetCode problem perfectly the first time around, you know? But there's plenty to learn if we ask ourselves the right questions about why we made mistakes or why we weren't able to actually get the correct solution to these LeetCode problems. And I think this is very paramount to when you're actually studying for your coding interview. So I'll show you my thought process, the questions I go through, and I'll be evaluating this as if I had made the mistakes myself. So with that, let's begin. So here you can see that I have the solution for my client. But let's actually step to this piece by piece. First, we notice here that he is actually trying to break down the problem. Root in every subtree, identify which parent-children relationships, separation at each level, and identify the leaves of the tree. Alright, now this is fine, however none of this actually drives the problem forward. If we think about it, root in every subtree is just a common definition of a tree. It doesn't add anything to our problem. So why would we put that here? Identify which parent-children relationships. Okay, yes, that is something we need to do whenever we are trying to decompose and serialize a tree. How do I know that if I serialize, A, B, C, D, how do I produce them in the order that I know that B, C, D are children of A? This is a problem that we ran into when we were doing the optimal solution. So because of that, I think this is a valid concern. Separation between each levels. Yes, that is also a concern. And if you think like this, you're probably going to go more towards the breadth first search situation. And I don't necessarily mind that, but I would say that this is a decent factor to think about. And it's an okay declaration. And the last one is to identify leaves of the tree. This one is just like, I don't see identifying leaves of the tree as any particular special case or something that needs to be actually handled that well. Because if we think about it, a root in every subtree could technically be a leaf as well. So, like what would happen is in the case of E, it would just be a node with no children. So this is like kind of pointless as a consideration. So we're spending some time thinking about things that are applicable to a general tree structure rather than things that are applicable to the problem. Well, half isn't that bad, but we can definitely do better here. Next, he actually tries to go through the solution, but I don't understand this. It's like, why is there da 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 da? Like why are these periods here? I assume that he's trying to solve the problem, but it's not apparent to me what each of these really mean. I mean, if we give him the benefit of the doubt and assume, hey, he's looking at the node and then all his children, then, this is probably the right path. However, I definitely would not represent it this way just because it does get a little bit confusing. And again, if you're not writing it down exactly, then the thought doesn't exist. So it's impossible for me to get any more benefit out of this line. Next, let's actually see how he wants to solve the problem. So he's generating another example. Okay, that's fine. He thinks that he is going to do something a little different, Maybe it's a simpler version of the tree that I'd given him. I'm perfectly fine with that. And so the way he wants to represent this looks like, the node first and then the children afterwards. Now, what he does here is this weird thing of using the parenthesis. Now, I know that I talked about this before in my previous problem about why it's suboptimal, is that you're using a lot of space for no reason, especially if the tree is sparse. And so, this is okay. I can live with this. I can live with this as a naive solution. I don't necessarily have a problem with it at all. I think this is perfectly fine. What he came to. So this is all right. You can definitely solve the problem like this. So let's see if he actually does here. So he's going to go through the serialize function. If not root, then return. Okay, I see what he did. So the way he's defining the node structure is that it's just going to be a list of node pointers. But these pointers can be null themselves. And I'm okay with this. I'm okay with this. So then now you have your DFS, and then you append your string to the root, and then for each one you will append a open and close breaks. This one I'm fine. Again, there's nothing that stands out to me as particularly incorrect, and this will get you the actual solution, because if there's no children, then it will produce nothing. So far so good. The only thing that was really a concern was that he actually just ended up like wasting a little bit of time here, but overall I think this is perfectly valid. So let's look at the second attempt here. So then he has this, that he should have realized that there is a null case. Yeah, I think that's fine. Just in case that your root.children has null. But personally for me, it just kind of depends on how you're structuring your data. I think this is kind of a little bit flimsy. It just depends on how you structure your node class. Because, you know, if it's like a Java list, then, and you only want to enforce non-null nodes, then it's fine. And in which case, if you want to insert null nodes, you know, that's kind of a function of how you set up the tree to begin with. But I can acknowledge this, I can respect it, but this is not really my biggest concern so far. So let's actually look and see how he did this deserialize function. Alright, so it looks like he wasn't actually able to get through the deserialize at all. So it's okay. Like, at least the serialization part was pretty alright. I think it's fine. I don't know why he did this, but I think this is actually pretty clean. He didn't actually write the code. I don't know if this is actually Python code, but I think this is actually perfectly fine for a DFS solution. Now, the fact that he didn't get to a deserialize is very concerning. So if this was me and I said, hey, I got through the serialize function, but I wasn't able to get to the deserialize, then my first thing would have been to try and solve this bit by bit. If I understand that I am introducing the node first and then the children afterwards, then all I need to do is reverse that process altogether. And so to just try to see what happens if I were to, you know, take it piece by piece. So this is concerning. This is already telling me that I am looking for some kind of weird YOLO, something that is going to come to me. So I think the lesson here is really to just remember to take things piece by piece. So let's actually mark all the things that I commented on. So like I said here, these identify the characteristics of the problem, which is fine, but again, these don't actually drive the problem forward. How can I create a cohesive narrative for actually solving this problem here? Instead of just trying out, you know, like identifying random things that may or may not pertain specifically to the problem. If there are things that are in general to tree problems, I probably don't need to list them. I can just implicitly talk about them. But, you know, if it's not written, it doesn't exist. So, okay, fine. But this is just like a red flag for me. Like, hey, maybe you might want to fix this. He's trying different ideas out. That's fine. And then overall here, if this is like a real actual concern, then maybe just walking through the own tree and walking through like some pseudocode might actually help you realize this. Because again, this is just a function of what your setup is for the node class. So overall, that's probably something to look out for. Maybe walk through an example like the way I did the optimal solution, and just, you know, test it. I think that's probably the best way to handle this. So now let's actually get to the big part, the deserialize function. So why was he not able to solve this? Because you need to be able to rewind the recursive string, and then you need to be able to represent all these what's called characters in a certain way. So every single time you look at a node or a letter, that you are going to be creating a node. If you look at the parentheses, you're going to start creating the children. So this is where you can start using a recursive stack or pushing the Z node onto an actual stack. And so basically what this boils down to is you do need to bite through this piece by piece, understand that what each of these steps really entail. After all, you've already identified that you have the node here and then you have the children. So this tells me that you don't really understand your own solution to begin with, and that's probably another lesson that needs to be thought. So let's move on to the next part, how to increase our time efficiency. Now, we might be able to solve a problem if given an infinite amount of time, but we want to eliminate all the false roads that we go down, all the bad thoughts. And so what I have all my clients do, and I highly recommend that you do it, is actually record yourself, your voice, and your the time it takes for you to actually do it. And I mean, like, have a running clock. So you can see me do this on my streams where I have OBS open and then I have a timer, and then I note at what timestamp I say what thoughts or do what things. And so I've done the legwork for you guys, and I've actually recorded the timestamp of my client actually doing all the work. So let's actually look at this here. So you can see here I have the timestamps of what he is actually doing and at what moment. And so because of that, I'm actually able to see like when and where the inefficiencies are. And so I highly recommend that you guys take the time to actually record yourself and really think about where you can improve in your problem solving efficiency. So let's briefly run through this. So in the first 5 minutes, he is trying out random ideas. He realizes that he needs to figure out what the inputs and outputs are, but he has no clear idea of where to go. And the next part is that he realizes that he needs to know what happens at each level in the tree, identify characteristics, etc., etc. All right. So basically, my first thing here is that when he's breaking down the characteristics of the problem and trying to set himself up, he's just spending so much time, like 10 minutes just trying to figure out the parameters of the problem, rather than trying to actually figure out how to represent it. In fact, like you can see here that he's not really able to think about this recursively properly. So for the first 15 minutes, this is already telling me that he is not comfortable with recursion. So if this was me, I would definitely take this first 15 minutes and highlight it and say, hey, I need to be much, much stronger with being able to process tree problems and recursion. If all I'm trying to do here is establish the parameters of a recursive problem, never mind actually trying to solve this particular problem. It's like if I'm just trying to figure out the parameters of a problem in general, then chances are I have not seen problems like this before, and I need to be much more familiar with it. So that's the first takeaway. The second one is that he realized that he's not able to really break the problem down. What I mean by this is that he's probably, like when he was actually writing this down, he was just, trying out random stuff. And so because of that, he's came up with this. This is probably where this actually comes from. He's like trying random ideas. He's not able to break it down. He understands that, hey, I need to be able to break up the node that I'm looking at, and then whatever happens at the bottom of the tree or below it, but he doesn't know how to take that next step. And really, a lot of times when you're solving problems, it's just really being able to take that one step forward after another after another. And so I'm seeing a pattern here. I'm seeing that with his deserialize, that he wasn't actually able to take that first step in a problem that he wasn't able to fully know what the solution is. So this tells me that, hey, if the solution doesn't come to me, that I don't know what the hell to do. And so this is probably the biggest lesson so far, that, hey, you need to be able to break the problem down. You need to be able to understand what you need to solve, and then where that leads to, etc., etc. And then just being able to break that big problem down into small, manageable chunks. So with that, next one. Realizes that he can use parentheses and that he can traverse things with a DFS. Now, this is something that you could have actually done at the very beginning, because when you need to look at a tree, and I think that in my optimal solution, I've already acknowledged that, hey, I'm going to visit every single node. And so I think I acknowledged this in my optimal solution, that, hey, I need to visit every single node. Therefore, I must do a DFS or a BFS of some kind. And so because of this should have been like the first thought. This could have been easily like saving him like 20 minutes already over here. And so because of that, he could have easily just like saved himself a lot of grief. Realize he can use parentheses to get in and out of the children. Yeah. So if I'm diffing against the optimal solution, this is like, I would have said, hey, this is the first insight I needed to have. Everything up to this point is pretty much pointless and wasted time. So what I really need to do is think about what I need to do to accomplish the problem and think about the implications. And in that way, I can actually begin to take that first step. Once I realize the implications, then I can pull on that string and then take the next step and solve for that. All right, next one. So I see that I made some deadly assumptions about the node. Okay, I assume that this refers to the actual null check here, and that he realizes that he needs to actually do this check. And so this means that he's actually able to write the code once he has the design and he fully understands it. But at the same time, we kind of said that he didn't really understand his solution, and therefore that this is kind of more or less a fluke. And so because of that, I think this here just tells me, hey, if you understand your design and you understand how to write your code, then you're actually able to write the code very, very quickly. I think this timestamp jump between 24 and 25 actually makes that very clear. So at least his ability to write the code once he has the design in his head is very good. But the problem is to be able to get there much more efficiently, to get through that design. And then the rest of this is just kind of like acknowledging that as well. He doesn't understand his own solution, and then he's using common parentheses. He's doing a bunch of random stuff. So overall, this is just basically a exercise in solving some DFS or tree-like problems, and that he is not very comfortable with it. So the takeaway here is really to make this understanding that if I have a tree problem and I need to traverse through every single node, that there is going to be some kind of implicit DFS or BFS that's going to be needed to be done. Anyway. So let's actually look at the annotations. So I've already written all this here. So we can say that, hey, if we're unable to think about this recursively or struggling how to represent this, then that means that I need a more general representation of tree nodes, and I need to be able to be more comfortable at handling those. So I'm just kind of retreading water here, saying, hey, he's not comfortable with recursion and tree problems. The next one here is why is he backtracking, and that if he can prove that his solution works in every single possible scenario and just walk through the example properly and just think about how it relates to his code, I think he would have a better grasp on how to actually solve the problem and be able to come up with a more convincing solution. And so because of that, I think that another way to solve this problem, or at least be able to improve your problem solving ability, is really just stepping through the example. Just once you have the design, just kind of step through the example and see what pops out. And this is something that I did actually in my own current problem when I came up with the optimal solution. This is how I was able to do it and kind of tweak it, see, oh yeah, this is actually what's supposed to happen, etc., etc. And being able to do that, I think troubleshooting it is actually very, very important. Next one, why do you miss the null case? It's just really again, it comes down to the class. But even then, if you said that there would be a null and you support it, then you need to be able to test it against every single case. Again, this kind of ties back to being able to think about recursive problems and tree problems in general. So had you just really started off on this step and you had a little bit more comfort in solving the tree problems, then I think this would have easily saved you the first 20 minutes of the problem. And so this is the big takeaway, I think, is just being able to do more DFS problems and to walk through the example. So let's actually look at how you would record this in a practice diary. And again, I highly recommend that you guys actually keep a practice diary of every single problem that you do and record all your annotations and lessons that you've learned on how to actually improve your problem solving approach. And notice here, I'm focusing on the approach. I'm never saying, hey, you should have been more careful here. You should have done X, Y, Z. You should have been less careful here and been faster. These are not actionable. What I'm doing here is really evaluating the approach I take and ask myself, why do I do this action? Why am I taking this approach? And then I'm handling the areas around it, because what I believe is that if you make an improper decision or a mistake, there's a reason why you made that mistake. Is that the context of the situation and whatever you're in led you to making that decision. If you were in a better situation, or you had better preparation or something like that, or some kind of better approach, you can avoid making these improper decisions, or in this case, inefficient solutions as well. Or should I say inefficient decisions. So let's actually look at a diary and see how I would have recorded this. So let's look at row 5 here. I see here, I'm going to say I spent 40 minutes on this. Well, my client did, but I'm, again, speaking as if I was the one doing the problem. And you can see here, it took me 40 minutes to do this, and that I only got through half of it. He needs to be more confident in the solutions and more methodic about the thinking of recursion and testing recursion, proving that the solution works in a general case, missing the null case, and in general, just really being able to walk through these solutions and just hitting that DFS really hard, recognizing that if you need to traverse through a tree, you need to include some kind of DFS in some kind of way. And not to mention, if you are a little bit shaky about your design, and even if you walk through it, you need to be able to have some bulletproof test cases that occur here. And so this means being able to recognize that you can break a tree down into a composite representation of nodes with 0, 1, or 2 children. In this case, N-Ary, so it's it has some children, has a lot of children, or no children at all whatsoever. So that'll do for me. Let me know what you think in the comments down below. Also, feel free to follow me on my socials, where you can vote for what topic I cover next. And if you want to try and secure the next job offer, or get coached for your next coding interview, or have me yell at you as you solve problems incorrectly and help you improve, you can book me for interview coaching at echantech.com. If you like this video, please like and subscribe, and I'll see you all in the next one.